My name is Heath. Some familiar faces here, so I know a few of you already. You can find me on Twitter, and you can email me. Feel free to email me if you've got any questions after this talk, or for any other valid reason. I'm a freelance developer, well, a bit of jack of all trades really. I've been working in software development for the last 19 years now, and I've been practicing BDD now for the last 4 years, more or less. And I'll tell you a secret. The first couple of years I was doing BDD. It didn't really work for me at all. I spent a lot of time trying to write my features properly and maintain my features and my step definitions. And I wasn't really seeing any benefit. So I was really desperate. And I thought this is not worth it. So I was really thinking of giving up. But I persisted, I continued and I persevered. And I got it to work for me. I got it in a state now, in a state where BDD is working really nicely for me. It really reduces my bugs per release cycle, and it really adds value to my development process. So what I'm here for tonight is basically to share all these lessons that I've learned with you, to make sure you don't make the same mistakes that I've made, and to make sure that BDD can work for you. So what we'll talk about here tonight, we'll have a quick introduction to BDD, obviously, because none of you knows what it is. And we'll talk about why it happens and how it happens, and what you get out of it. And we'll talk about the mistakes that you can make while practicing BDD, and you can avoid the mistakes. And I'll give you some tips and hopefully some helpful advice. Now, we can't talk about BDD without talking about burning the toast. Does everybody here love toast? Yeah? Right, hands up if you love toast. Yay. Everyone. Toast is amazing, isn't it? It's like one of these all-round foods. You can have toast with butter and jam and honey and peanut butter. Or you can have savoury toast, with beans and cheese and ham. It's fantastic. It's really great food stuff, But I'm digressing. Now, I want to talk about toast because I've got a little ritual every Sunday morning in bed with my wife. I don't know what you're thinking. I like to make breakfast for my wife in bed every Sunday morning. So I wake up early and I go downstairs in the kitchen and I make some toast, and I make some nice coffee, and I put it all on a nice tray, and I put some butter and some marmalade and some jam, and I take it upstairs to Julie. Now, my wife, Julie, is just very finicky. She's very fussy, and that's why she married me, right? And she likes things just so. So she likes the toast just so done, not too crispy, but not too soft either. So what normally happens, I will take the tray with the toast upstairs, and she'll have a look at it and say, "Oh, Fred, you burned it." So I'll take the toast downstairs to the kitchen again, and I'll get a butter knife, and I will just scrape all those burned bits off the toast. And I'll put it back on the tray, take it upstairs again to the bedroom, I'll give it to Julie. And sometimes I'll get it right and she'll be happy. But some other times I'll have scraped it too much and it'll be like, half the toast will be gone. So I'll take it back again and do the toast all over again. And eventually I get it right. It takes me 3 or 4 tries, but I get the toast perfectly done, and Julie loves it. So why am I talking about toast here tonight? Well, because the way I make the toast is the way we normally make software. How do we traditionally write software? Well, we have some requirements, some ideas. We start writing some code, and we write some tests for the code. When we're happy, we give the code to the testing team. And the testing team exercises our code and says, "Fantastic, it's perfect." And we ship it out to the stakeholders, to the users, to the customers. Yeah? There's some smirking faces there. That's not how it works, is it? How it really works is that we write the code, we give it to the testers, and the testers say, "Well, I'm sorry, but it's not quite working quite right. There's some problems. It's not how we expect it to work." So they give us a code back, and we take the code back into our development environment, we change it, and we give it back to the testing team. And the testing team say, okay, this bit is now working fine, but that other bit over there is not working the way we expect it to work. So we go back and forth again with the tests quite a few times. So we have this kind of loop going on. And eventually we get it right. And we have some nice software that works as expected, and we give it to the testing team. And the testing team can ship it out to the stakeholders, to the users, the customers, the product owners. And as I said, it's working fine. But it takes us a few iterations, it takes us a few going back and forth. So what we're doing here, basically, we're burning the toast. We're burning the software toast. And we have to take it back, scrape it, ship it out again, and take it back, make a new toast plate maybe sometimes, and we have to go this process. And I don't know if you're happy with it, I'm not happy with it. It's a lot of time and effort wasted to get the software working right. So how can we fix this? Well, that's where BDD comes into play. And the way we work with BDD is this. So we start from the outside and we move inwards. So we start with stakeholders. We sit down with the product owners, with the project managers. We sit down with the customers themselves if necessary, the business analysts. And we define how a system should behave. And the way we do that is that we write down the features. What's a feature? A feature is a natural language description of our system's behavior. So we write down in plain English, or French if you're French, or Russian if you're Russian, how the system should work. And it's just plain structured English, there's nothing peculiar about it. Let's have a look actually at one feature, just to see what it looks like. So here we have a feature for a traffic data website. And we're working on a feature called a REST API for accident data. And as you can see, we have a small story at the top, which is basically a description of how the feature should work. And the main actor here, the main thing that uses our feature, is a visualizer web service. And the visualizer web service basically just goes through a REST API, gets some data, and places on a nice map. That's all it does. So we have the basic story, which is the description of our feature. And then we have a scenario. And the scenario is the basic scenario here. I would call it the happy day scenario. That's what I normally call it. I won't call it that here, because obviously it's accident data, so it's not really appropriate. But it's a basic scenario. And what we do, we just basically describe the basic behavior of our feature, which is given that there are certain accident data in our database, then when I go to our URL path, then I can get the data successfully. It's as simple as that. Okay? And as you can see, the scenario is still in English, but it's structured. It's got a certain structure to it. It's given a precondition, when an action happens, then expect a result. So it's precondition, action, result. So as you can see, a feature is just an English written file, but structured in a certain structure. So once we have the features, what do we do next? Well, now we go and create some step definitions. Okay? What's a step definition? A step definition is basically just some code that exercises our feature, exercises our behavior. And if we cast our mind back to our previous feature, we remember there was a step that said, given that there were some accident events in a database. So we have some step definition that matches the exact step in our scenario. And we have some Ruby code in this case that actually goes to the database, gets all the accident data, and just makes sure it's all there. Simple as that. And there was another step in our scenario that basically said when I go to this particular URL, this particular path. And we have here a step definition that matches this step, the scenario step. And again, we'll just have some simple code that actually goes to that path and make sure it gets back some data successfully. It's as simple as that. Yeah? We just exercise our feature, exercise our behavior. Okay, so we have our features, we have our step definitions. So what do we do then? Well, what's going to happen now if we start running the code for our step definitions? If you remember, the first step goes to the database and tries to get some data out to check that the data is there. Of course, there's no database and the data isn't there. So if we run our step definitions at this point, they will just fail. Yeah, we get an exception. So we go into our system and we create a database and we put some data in it. Similarly, the next step goes and tries to access a URL. Well, at this point in time, there's no URL there, there's no web service. So we create a simple web service with one URL, one path, and we just make sure that it can be accessed successfully. So then we write our code. So as you can see, we started writing the code only after we wrote features and step definitions. Now that's a big paradigm about BDD. We never write code randomly. We start writing code specifically to meet the step definitions. And of course the step definitions are just basically exercising the behavior of the system, or features. So effectively we're writing code to meet our features, but make sure that the system behaves as our features say it should behave. Nothing more, nothing less. There's a number of different tools you can use in BDD to help you try it out. And probably the most famous one is Cucumber. You go to Cucumber. Cucumber is basically a Ruby tool. There's now a Java port of Cucumber as well. But if you come from different environments, there's Behaviour for PHP, there's JVA for Java, Letters for Python. There's quite a few tools. And they all do basically the same thing, more or less. They can actually allow you to write some features, write some step definitions, and write some code, and make sure that the features match the code and vice versa. Yeah? So at any given step, you can see exactly if your code makes your system behave the way it should behave. So why do BDD? What's in it for you? What's in it for us? Well, obviously the major contribution that BDD makes is to make sure that everyone talks exactly the same language. We have our features that are plain, natural language files. Anyone can read them. Anyone can know exactly at any time how the system should behave. And because everyone knows exactly how the system behaves, then everyone knows exactly what to expect from our system. There are no low expectations, no over expectations. Yeah? Everything is clear and unambiguous. And of course, BDD itself, the actual feature files, can be used as living documentation of our system. So if someone stops you in the street and says, "Excuse me, sir, or madam, how does your system work?" you just point them to the feature files. That's how my system works. Okay. Now, I mentioned all these BDD tools like Cucumber. What they do is that they give you measurable progress. So at any step in the development process, you can actually run Cucumber or JVA or whatever, and you can see exactly how many features and scenarios are actually working. That means how many scenarios, step definitions are actually have some code that does exactly what they say it should be doing. So at any given time in your process, you can actually get a full picture of where you're at with your system, if it behaves the way you want it to behave. And, I personally can vouch for the success of BDD because I had a lot of it myself the last couple of years. But, there's some famous cases out there. One of them is the Bellatrix SF, a consultancy that went to one of the clients and they applied BDD, and they got a reduction of bugs per cycle down from 30% to 2%, which is a huge reduction really. This is quite remarkable. And of course, closer to home here in Britain, we have Capita Consultancy, you might have heard of them, and they applied BDD to one of the clients and they actually got 0 known defects after release, which is a fantastic achievement really, it doesn't happen often. Actually, Capita in this particular case, they got the regression test time for this customer done from 2 weeks down to 2 hours, I believe, or something like that. And it's because they managed to automate all the step definitions, all the behavior codes. Yeah. So instead of having a number of testers sitting there for 2 weeks, making sure the system worked right, they got in 2 hours all automated. So that's one of the side effects of using BDD.